Welcome back, everyone, for the last time. We are finally on the science test. This is still the same form that we've been using this whole time. I liked how we didn't ramble on for a long time, so I'm going to just say that we have 35 minutes for 40 questions. So the timing, if you saw my timing video thing, I'm going to try and do 5 minutes per passage, which is on the conservative side as far as time goes. And then we'll go a little bit slower on the opposing viewpoints ones and a little bit faster on the data representation ones, but in general, about 5 minutes per passage. That's what we're going to try to stick to. So far, I haven't really stuck to what I've been doing throughout any of these, except for maybe the English, but we're going to try. So we're shooting for a 36. Usually we do okay on these, or on the science anyway, but yeah, I don't have much else to say. I got my watch and I've got my pencil, number 2 pencil. Got a bubble sheet. I have everything linked in the description. So if you want to print it out, follow along. That's about all I have to say. So watch is at the ready. And we're just going to take this 35 minutes, about 5 minutes per passage. Okay, ready? 3, 2, 1. Cool. Got a timer on the screen as well. Jumping spider. Researchers brand. Okay. Cool. So I read experiment 1. Now I will scroll down. Okay. What can we do? Each of the values plotted in figure. So I'm looking at number 5. Each of the values plotted in figure 1 is most likely calculated. Which the following expressions? Okay. The average number of crickets of each color eaten in 1 hour is shown. What? How long were they in there? Oh, okay. Total number of crickets that were eaten by wild-caught spiders divided by wild-caught spiders. Oh yeah, so it would be D. Because it's, yeah, I think so. Yeah, what? They had laboratory-raised spiders. Alright, yeah, so that was D. Number 5. And then moving on from that, what else can we answer based on experiment 1? There's a total, I'm looking at number 3 now, 1 through 3. So we had 99, so we had 100 in the first one, 100 in the second one, 100 in the third one. So 300. It's a weird question. So number 3 is C. Student wanted, okay, so I think we have to read the rest. Okay, wait, number 2. Were the results of the experiment consistent with this? No. In each experiment, the spiders ate more blue crickets in an hour. Did they? Yes. 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 So that one would be J for number 2. You need to hurry up. Repeated experiment 3. Okay, now we read again. Experiment 1 was repeated. Using the same set. Okay, so they only used 200. Oops, so that's B for number 3. Okay. Which had been kept in the cages from the laboratory for is the average number of crickets is shown in figure 2. Experiment 1 was repeated except with. Okay, these are weird. Suppose that in a new I'm looking at number 1 now. Suppose in a new experiment, the researchers repeated except they recorded the color during 2 hours. the total number of crickets eaten by the spiders will likely have been less or more than the number eaten in experiment. Yeah, what do they do? They just stuck them in there for an hour. With the total number eaten greater because the amount of time that they spent. Yeah, I think that'd be C, because they spent an hour in there. From the description of the study, that's what they did. Cool. What are we on now? 4. A student wanted to determine if the results for the wild-caught spider tested shortly after they were captured would be the same for different species of prey. Repeat experiment 1 with a species of prey other than A. domesticus. Yeah, so that would be H. I'm very slow at this. Okay, hurry up, bro. Which of the statements is consistent with the information? Okay. They were all the same species and all the same genus, right? Yeah. Both that and that. And then 7, after the wild-caught spiders, they ate, on average, more crickets than if they had been recently captured. More green if you. They ate less on average. That's what it looks like to me. But I don't know. They ate less green ones. Wait. Can it be both? I'm so confused. I'm still taking forever. Why do they say experiments 1 and 2 and then have stuff about laboratory raised spiders? Which is best supported by experiments 1 and 2? Oh, okay. I'll just say fewer than they did if they had been recently captured. Okay, we are taking far too long. I'm just really tired right now. Indian beech tree produces oil rich seed. I'm gonna stop talking. Okay, that's so loud. The oil is inevitable, however. Scientists study them. Great. Okay. 20 milliliters is. I'm not even gonna read that. All right. So they have a catalyst. Oh wait, what's the concentration of? The amount of biodiesel fuel and the percentage that had been converted to biodiesel fuel had been calculated. The combination of conditions for trials shows average for each of the set of the trials. Oh my gosh, they're so loud. Okay, we only have 3 minutes to do this, and I'm hitting a wall in my head. I'm so tired. The table shows for each experimental conditions the average. Okay, I understand. Oh, catalyst. Okay, now I know. What step was most likely performed to stop the reaction that was occurring in the flask? Step 3. Oh wait, step 5. They dissolved it and then they microwaved it. Okay, I guess number 5 or step 5. I'm just gonna really hurry up here because we have 2 minutes. According to the table, which a combination of catalyst concentration, lowest average percent of think that's D. Consider the results. Okay, we have 1 minute to finish this. Each combination catalyst, blah, blah, blah. Compared with the average percent converted to biodiesel fuel in the NaOH, the average percent in KOH is sometimes higher and sometimes lower. Yeah, it's sometimes higher and sometimes lower, I think. So that's J. Great. Which of the following gives the volume methanol used in the experiments? What? 80 milliliters of methanol per trial. And they did 44 trials. Is it 80 milliliters or 100 milliliters? Oh, this is so annoying. 20 milliliters of oil was mixed with 80 milliliters of methanol. And they added catalyst. Great. Please work B. Okay. My brain is like... the average percent of oil converted to blah, blah, blah. Differed from that because the two sets differed with respect to 25 to 28 versus 33 to 36. They were different catalysts. Yeah. F. The trial is conducted with 1% hydroxide. As the microwave time, the average percent, I think it's probably increased only. We'll go back to it though. The solution formed in step 1 of each trial had a mass of 82 grams. The mass of the catalyst added to the flask in step 2 of trial 5. Okay, we're still over time. The solution formed in step 1 had a mass of 82. Based on the information on the table, the mass of the catalyst added to the flask in step 2 of trial 5. What does that even mean? Trial 5 is 1%. Man, this is annoying. Okay, what? Solution formed in step 1 of each trial had a mass of... How? You said there's... Oh, okay. Gosh. Oh. The mass of the catalyst added to the flask in step 2. Trial 5 is 1% by mass. So I'm just going to take 1% of that, right? Which is G. That's probably completely wrong. Whatever. Okay. Heating degree days and cooling degree days are used to estimate the amount of energy needed in any building. Daily mean temperature from the base. Okay, TD. What the heck? HDD are calculated by subtracting the mean temperature from the base. CDD are subtracting... Okay. Okay, great. Please have a question on that. Doesn't. Great. Okay, I don't even know what I'm doing. Table 1 lists for 10 U.S. cities the latitude of the city and the city's total HD and CDD for a year. Okay, can you ask a question, please? According to figure 1, did the maximum HDD occur in the same year as minimum CDD? No. The max occurred in 1996, or the minimum CDD occurred in 1992. Yeah, that's D. Okay, based on table 1 in Dallas, the total CDD was approximately how many times as great? CDD, Dallas, I can't even find, okay, let's see, about 8 times, what? No. Gosh. 100. 10. Okay, 10 times. CDD to HDD. CDD was 10 times as much as the HDD. It's J. I suppose in Dallas it's hot. For all cities between 40 degrees north, in a 1 year period, okay, I'm looking at Seattle, and the HDD is less than the CDD, so HDD was always greater than 2,500. That's true. All right, there we go. So that's A. Yeah, I'm dying. Yeah. Assume that on a picture day, blah, blah, blah. For this day, what HDD value will be calculated and what CDD value? Oh, they're both 0. Okay, cool. Please give us more of those questions. Which of the following illustrates the latitude and the CDD for each of the city? Southern to northern, did it increase? Actually, which was a high? Wait. Was it southernmost the, what's this, CDD? Was it southernmost the lowest CDD? I doubt it. It'd probably be the highest. Okay, so it went low. The lowest one was the second to the highest CDD. The lowest one was the second to the highest CDD. The lowest one. Second to the highest CDD. So would that be A? I think that would be A. Great. I'm not going to check that. 20. Consider the Hdd equation, the Hdd trend line. The slope of that trend line is negative, which indicates that the average value of Td remain constant. What is Td? Is that the daily temperature? Oh. Okay, so CDD is Td minus 65. So it's going down. Then Td would be getting smaller. Yeah. Td would be getting smaller. Gosh, this is so annoying. Yeah, decreased only, so that'd be F. Great, move on. We are still behind. The amoeba that can infect the human digestive tract. Scientists conducted 2 experiments to study the amoeba killing human milk. What? That's so weird. Okay. 10 milliliters of nutrient medium in saline solution. That's 5% saline. Was put in a test tube. Um, 10 milliliters of only the nutrient medium was put in a 4th test tube. So 1 times 10 and then... Man, that is so weird. All 8 test tubes were incubated. At the end of incubation, the percent survival. Great, that makes perfect sense. Okay, which of the following questions were they attempting to answer? Is the percent survival exposed to SS affected? No. Is the percent... I think it's J. The percent survival for the amoeba exposed to human milk different than, yeah, that'd be J. For 24. And this is annoying. The dye trypan blue was added to each test tube. Dead or stained, living or not. Approximately what percent were stained? 10% human milk. Man, that is such a weird experiment. 21%, 20%, sure. B for 25%, or 25. An E histologica persists which is the following person. Oh boy. An amoeba is unicellular. I think it's A. I don't even know. Didn't learn about amoebas. Sure. Okay. Now we read experiment 2. Sample of human milk was separated into three, casein, lipids, and non-casein. 10 milliliters of nutrient medium and SS, that was 10% by volume. Put in a test tube. This procedure was repeated 3 times, except that different milk fraction was... Man, that's so weird. Were added to each of the test tubes, and two more sets were prepared. Each set was incubated for a different time. Okay, great. That's a ton of information. In experiment 2, at each incubation time, which fewest? Okay, that's easy. Non-casein protein. Great. 21 is D. Man, we have to hurry up. 21 is D. 22. Experiment 2. There a substantial decrease in survival. Absence of a human milk fraction. It's all 3 incubation times, right? Yeah. They put in saline solution. Dude, this experiment is so weird that they took human milk and put amoebas in it. Like, some of these are usually interesting, but this is just weird. 26. Let's compare the killing thing for the milk fractions. The activity of human milk that has not been separated. It should, what? To compare to the... Oh, okay. Where's that? Human milk and NM. Oh, I guess it's J. Except include a test tube containing a mixture. Great. My brain is already fried. Is that all of them? No, 23. Suppose that an incubation time of 12 hours had been used. Percent survival, lipids. It's basically the 80%. Cool. Percent survival. Yes. See later. Okay, great. 2 identical copper cables. Great. Each switch had 3 positions, X, Y, and off. Teacher flipped both switches from the off to position X. Tails bent towards each other. Y, then to away, flipped the other switch, and Y. Oh, interesting. And then they have viewpoints. Cool. Dang it. Okay. The switch is controlled in the direction of current flow through the cables. Cool. Each current generated an electric field because each current consisted of positive charges. Its field pointed in the electric fields attract each other in the parallel and repel each other in anti-parallel. The field generated by one current attracted. That doesn't make... What are you talking about? The field generated by one current attracted or repelled. The field generated. Makes literally no sense, but okay. The switches controlled the direction of the current flow. However, the currents consisted of negative charges. Each current generated a magnet. Actually, wait, we can just go to... Student 1, please. Anyone? Okay. When the switch on the left was in X and the switch on the right was in Y, were the electric fields parallel or anti-parallel? Anti-parallel because the left-handed was flowing up and the right hand was flowing down. Yeah, that'd be C. 31. I'm doing way too much in my head, but... In regard to attractive and repulsive interactions, how does student 1's explanation differ from student 2's explanation? A field attracts or repels. What does student 1 say? Electric fields attacked or repelled each other. Okay, what does this even say? Field generated by one current. Great. Currents were anti-parallel. Field generated by one current repelled them. So when they're anti-parallel, they were repelled. Man, this is weird. What were we even on? Okay, 33. In regard to attractive and repulsive interactions. Okay, so he said a field attracts repulsively. Okay, I think it's A. 33 is A. Maybe. We'll go back to it. We only have 10 minutes. Which of the following would test student 1's current flowing through one cable determined if positively charged plastic rod when held at rest attracts a repulsive cable? Sure. That's magnets and uncharged. Yeah, I think that's F. I don't even know. I think so. It doesn't. Oh, we already did that. The student 2's explanation is correct. Then a magnetic field would be expected to exert force on which object? An ion in motion, for sure. It's the only one I'm sort of sure of, but sure. Okay. Each of the following statements was either 29. Assume that the currents. The demonstration consists of a single type of charge. Student 2. Okay. Not photons or neutrons. He said negatively charged. Okay, so that'd be electrons. 29 is B. Each of the following statements was either claimed or implied by student 3. We don't know that. Cool. The switches control the signs of the charges, positive and negative. Regardless, the charges repel. What? Like sign attract and opposite repel. Great. That'd be this. Okay, yeah, I think that's F. Okay, 32. It's consistent with both. Okay, he said Y was positive in X and negative in Y. Positive in X and negative what? Switches control the signs of the charges in the currents. Positive in position X and negative in position Y. Oh, I guess so. It's just saying X and Y. So that'd be H. I don't even know what student 2 was saying. Oh, okay. Student 3. It said figure 2 in student 3's explanation. Great. Are we behind by an entire passage? Are we done, please? Okay, I think we answered all of them. This is horrible. Okay, figure 1 shows how the vapor pressure varies with relative humidity at... Okay. Figure 1 is vapor pressure varies with humidity. Figure 2 shows how air density varies with H2O, vapor pressure. Great. It's not figure 2. Will a 1 liter sample of air at CTP have a greater mass? Oh, gosh. Oh, 1,000 or 2,000. Okay. Greater mass if it has 1,000 or 2,000 pascals. Greater mass. What? Oh. Okay, air density. Goodness. It'll be denser if it's 1,000. Yeah, so it's G. Great. Oh wait, that's 38. Whoops. Bubbling in the wrong ones. Cool. Consider two 20% biomass aqueous solutions in a separate H2O vapor. Whoa. Will be greater in the air. Vapor pressure will be greater in the air above that, and it will be in the air above that. How do we, does that say that anywhere? Oh, okay, at CTP, the air above an aqueous solution has a constant relative humidity. For three compounds, how the relative humidity varies with the percent by mass. So it said 10%. I mean, they're all the same. So H2O has a higher relative humidity than sodium hydroxide, or H2SO4. Okay, so it's not those two. Higher relative humidity. Okay, higher relative humidity and vapor pressure. Which one will have the higher vapor pressure? Higher relative humidity, higher vapor pressure. Means H2SO4 will be the higher vapor pressure. So, okay. Yes. J. Oh man, we're taking forever. Consider a 35% by mass aqueous solution of sulfuric acid in a closed container. Air above the. Okay, thank you. Ask more of those. 35%. That's like 70. 70 what? What am I even talking? 35. If the air above the solution, the density of the air. Okay, so we have 70% relative humidity, which corresponds to about that 2250 vapor pressure, which is about it's about over here. So 1174. Wait, but more than that. 2250 to 50. I think. Oh gosh, I think it would be B. We'll go back to that. Okay. According to Figure 3, if pure H2O is kept in a closed container, the relative humidity will be. How am I supposed to know that? Oh my gosh. How is that based on Figure 3? Oh man, this is annoying. Oh! Never mind. Okay, if the concentration is 0, the relative humidity will be 100. Nope. That's D. 35, 37 is D. Okay, we have 2 minutes. 35 and 36. As relative humidity increases, air density. As relative humidity increases, vapor pressure increases. As vapor pressure increases, air density decreases. So it would be A. This is based on Figure 2, air at CTP that has a density of that will have an vapor pressure closest to air that has a density of 1172. Air that has a density of 1172 will have a vapor pressure closest to. Oh, come on, man. How much time? Okay, we have a minute and a half. How am I supposed to know this, bro? Okay, it goes like 400 every one. So, less than 400. So, I guess 2700 would be G. Great. Okay, which ones do we need to check? Need 39. Whatever we guessed. I don't care. 33. In regard to... okay, yeah, student one. Okay, yeah, I think so. 19. Oh, I don't need to check that. 13. No, we don't need to check that. Alright, I'm gonna go back down to 39. What is that? Okay, 39. We're almost out of time. 39. Yeah, we're gonna, okay, 35% by mass aqueous solution of sulfuric acid. 35% by mass. That is around 70%. A little less than 70%. So then that would be around 2200. Yeah, let's just say 2200. And then 2200. I think we're out of time. Yeah, okay, we're out of time. I think that was right, though. Great, that hurt my head a lot. That was not worth taking at all. Okay. We're done. Done. We're done with this ACT for the final time of being done. I don't know. Sorry. Okay. That was fun. There's a lot of uhs and ums. Yeah, I was half silent like that whole time because I was trying to actually do it. So I might add some edited text in to enlighten you as to what on earth was happening. But otherwise I'm gonna grade this. If we get a lot wrong, I'll add some corrections. But otherwise, great job on finishing this ACT. You guys showed real commitment, sticking with a person who hasn't a clue what they're doing. But good job. There are a lot of ACTs if you just look them up. Look up like ACT tests Reddit, and there's like 80 of them. So the practice doesn't stop here. If you really, I don't know, all you have to do really to do good is just do a lot of practice tests. Obviously, no, like in English, practicing isn't going to teach you grammar rules. But like English is the only one that you really need to know those, besides like math formulas as well. Once you have those down, just like take a bunch of practice tests and you will hopefully figure out or diagnose what you actually need to work on. I don't know, that was extremely helpful for me. So doing these types of practice things is very helpful, so good job to all of you people. I'm going to grade this now and then post it, and then probably post our composite score from like the whole test. And then, yeah, I guess we'll see. In the future, I don't know, if you want me to do another one of these, I might, or at least another math section to redeem myself. But in the future, I might just try doing it completely silent and like put like closed captions or something, because it's so hard to talk and think at the same time. I don't know. I'm gonna grade this. I've talked for too long. Good job on finishing this test. And there are more resources out there if you want to continue your quest for knowledge. But otherwise, I'm going to end this screen recording. Good job again for the last time, and we are done with this entire form B04 or whatever it is. So yeah, good job. Where's the top? There we go. Satisfying. But otherwise, good job for the last time again, and goodbye for the last time.